Today, we're talking about what is, without a doubt, humanity's ultimate time machine, the James Webb Space Telescope. And look, this isn't just about taking more beautiful pictures of space. This is about seeing light from the very dawn of the universe, looking back to a time before the Earth even existed. So, let's start with the question that drove this entire thing, one of the most ambitious projects in human history. What if you could actually see the past? I mean, really see it. Not just read about it in a book, but watch as the very first stars flicker on in an otherwise dark universe. That, right there, is the whole idea behind this telescope.
And to make an idea like that a reality, well, it takes an unbelievable investment. We're talking about a $10 billion price tag. Think about that. This wasn't just another satellite project. This was a generational bet on our own curiosity, a commitment to answering the biggest question of all. Where did we come from?
And it wasn't just about the money, not even close. It took a quarter of a century of brain power, of dedication, of solving problems that had never been solved before. Thousands of scientists and engineers from all over the world poured their entire careers into this one single machine.
And after all that money, all that time, all that human effort, its success came down to a terrifyingly precise, robotic ballet in the total darkness of space. There were 344 single points of failure. If just one of those things went wrong, the whole mission, $10 billion, 25 years of work would have been lost. Poof, game over. No second chances, no rescue missions.
So here's how we're going to break down this incredible story. First, we'll look at Webb's main goal, hunting for that first light. Then, we'll get into the wild physics that makes it possible, the engineering miracle of its deployment, and, of course, the mind-bending discoveries that are already rewriting textbooks. We'll also see how it teams up with Hubble, and finally, we'll look at what's coming next on this amazing cosmic journey.
All right, let's start with the big why. Why go through all this trouble in the first place? Well, the entire project really boils down to 4 huge questions about the universe, questions we simply couldn't answer with the tools we had.
So, what are these big questions? First, how did the lights turn on in the universe? Webb was built to see that cosmic dawn. Second, how did the first tiny baby galaxies grow into the giants, the cosmic cities that we see today? Third, how are stars and planets even born? Webb can literally peer inside those dusty stellar nurseries to watch it happen. And finally, the big one. Are we alone? Webb is designed to sniff the atmospheres of distant worlds, looking for the building blocks of life.
So you have these huge goals, right? But here's the catch. To achieve them, especially that first one, you couldn't just build a bigger version of the Hubble telescope. You had to see the universe in a completely new way, in a type of light that is totally invisible to our eyes. You had to build an infrared observatory. And the reason for that comes down to one amazing concept: cosmological redshift. Here's the deal. The universe is expanding. As it expands, it literally stretches the light traveling through it. Imagine you draw a wave on a balloon and then you start blowing it up. That wave gets longer and wider, right? The universe is the balloon. So light that left the very first stars as bright, energetic blue light has been stretched for over 13 billion years. By the time it finally gets to us, it's not even visible light anymore. It's heat. It's infrared. And that is precisely what Webb was built for. It's a giant, super-sensitive cosmic bucket designed to catch these faint, ancient, stretched-out whispers of heat from the past. This isn't just a small step up from Hubble. It's more like humanity has been living in a silent movie and someone just turned on the sound. We now have a whole new sense to perceive the universe. So, knowing the science is one thing, but how in the world do you actually build this thing? I mean, just think about the challenge. You have to build a telescope the size of a tennis court, fold it up like origami to fit inside a rocket, launch it 1,000,000 miles away from Earth, and then have it unfold itself perfectly. It is absolutely insane engineering.
The whole thing is just packed with genius ideas. You've got the primary mirror, a staggering 6.5 meters across, made of 18 gold-coated hexagons. They use gold because it's fantastic at reflecting that infrared light. But to see that faint heat, the telescope has to be incredibly cold. That's the job of the sun shield. It's 5 layers thick, each one thinner than a human hair, and it acts like a giant beach umbrella, keeping the telescope at a frosty -23.5 Celsius. And it does all this while parked at a special spot 1.5 million kilometers from Earth, called the L2 point, where it can stay stable and cold. So after it launched on Christmas Day, the entire world watched and held its breath for what became known as 29 days on the edge. This was the most complex robotic deployment ever tried. Minutes after launch, the solar panels came out. Easy enough. But the real nail-biter came about a week later, when over 100 different mechanisms had to fire in perfect sequence to unfold and tighten that massive sunshield. Then the secondary mirror clicked into place, and finally, the two wings of the main mirrors swung forward, completing that iconic honeycomb. Every single step had to be perfect, and somehow it was.
So the telescope unfolded, it cooled down, it focused its mirrors, and then it opened its eyes. And almost immediately, the data it started sending back began to, well, break our models of the universe. What it found was, in a word, impossible.
This quote from George Ricci, one of the key scientists, just perfectly captures the shock that went through the astronomy world. The very first deep images showed galaxies that were far too big, far too bright, and far too developed to exist so early in the universe. Our theories said they needed billions of years to grow, but Webb was finding them when the universe was just a toddler.
For example, it spotted galaxies just 300 million years after the Big Bang that already had oxygen. Now, you only get oxygen from stars that have lived their lives and died. So that means a whole generation of stars had already come and gone way, way earlier than we thought. And then there are these things called little red dots. They turned out to be supermassive black holes that were growing faster than their own galaxies. That's totally backwards from what we thought, completely flipping the script on cosmic evolution. But maybe the most tantalizing discovery of all comes from an exoplanet called K2-18b. In its atmosphere, Webb found hints of a molecule called dimethyl sulfide. Now, why is that a big deal? Because here on Earth, that gas is almost exclusively produced by life, specifically plankton in the ocean. Now, we have to be clear, it's still being debated, but the very fact that we can even look for potential signs of life on a world light years away, that's a complete game changer for all of us.
Now you might be wondering, okay, so is Hubble just obsolete now? And the answer is a huge, definitive no. They're not competitors, they are partners. Webb isn't Hubble's replacement, it's its successor, built to see the universe in a way Hubble can't, and vice versa.
The key differences are what they see and where they see it from. Hubble is the master of visible and ultraviolet light, the light our eyes can see. Webb is an infrared specialist. Webb's mirror is almost 3 times wider, so it's way more powerful. And while Hubble hangs out close to Earth, Webb's super cold, super distant orbit is the secret to its incredible sensitivity.
And you can see this teamwork perfectly in these images of the famous pillars of creation. Hubble's view is iconic, right? You see these incredible smoky columns of dust, but you can't see inside them. Then Webb takes a look, and with its infrared eyes, it just pierces right through that dust, and suddenly, bam, you can see thousands of newborn stars that were completely hidden before. One shows you the cradle, the other shows you the babies inside. You need both to get the full story.
And for all the amazing stuff we've just talked about, here's the most exciting part. We are just getting started. The telescope is actually performing better than anyone dreamed, and it has enough fuel for maybe 20 years of science. The journey is really just beginning.
So what's on the to-do list? Well, scientists are still pushing to find the Holy Grail, the true first generation of stars, forged only from the elements of the Big Bang. They're also going to start building huge catalogs of exoplanet atmospheres, not just looking one by one. And closer to home, Webb's going to give us our best ever views of our own solar system's mysterious ice giants, Uranus and Neptune. And it will team up with the next wave of telescopes to keep pushing the boundaries of what we can see. You know, when you really step back and think about it, the James Webb Space Telescope is so much more than a machine. It's a monument to human curiosity and what we can do when we work together. 3 space agencies, thousands and thousands of people, over 100 million hours of labor, all to turn a wild vision into a reality. All to help answer that one simple question, where did we all come from?
So let's end with this thought. In just its first couple of years, this telescope has shown us galaxies that our theories said were impossible and found molecules that could, just maybe, hint at life on other worlds. It really makes you wonder, what other incredible secrets has the universe been hiding, just waiting for us to finally build the right pair of eyes